Hello everyone, welcome back to my channel Study With Me. Today I'm going to explain about Chemistry Higher Level Paper 2, May 2022 Time Zone 2. If you find this video is helpful, don't forget to subscribe and let your other friend knows about my channel, so this will also support me to talk about other past papers. And let's get started. Lithium reacts with water to form an alkaline solution. Determine the coefficient that balances the equation for the reaction of lithium with water. Okay, so we have 1H here and 2H here. So therefore, the total 3, but here is 2. So let's make it to be 4 by adding 2 right here. Therefore, the H will be 4 by adding 2. And Li will become 2, and now O becomes 2, and here O also 2. H total is 4, and here also it's 4 if we add coefficient is 1. Okay, calculate the molar concentration of the resulting solution of lithium hydroxide. So to find concentration of lithium hydroxide, we need N divided by V. So we have volume is 500 centimeter cube, which is 0.5 decimeter cube. So we need mole, but mass of lithium is known. So we can find mole of LiOH by doing mole ratio. First, let's find the mole of Li, which is 0.2 divided by 6.94. You get 0.0288 because the coefficient are the same, therefore the mole will be the same as well, 0.0288, and you will get 0.0576 mole per decimeter cube. Calculate the volume of hydrogen gas produced in centimeter cube if the temperature was 22.5 degrees Celsius and the pressure was 103. Okay, so to find volume of gas, this is the equation. So we can rearrange this by divided by P. So we have gas constant, and then temperature just at 273, and then pressure is also known, but not for mole of H2. But as you can see, mole of H2, coefficient of H2 is half of the Li. Therefore, the mole will be half. So NH2 will be half of mole of Li. So you will get 0.0144 mole. So 0.0144 times gas constant, and then times temperature, which is 295.5 after converted to Kelvin, divided by pressure, and times 1000, because the volume that you will get will be decimeter cube, but the question asking in centimeter cube. So you will get 343 centimeter cube. Suggest a reason why the volume of hydrogen gas collected was smaller than predicted. Okay, so it means there are some error in the experiment, like maybe gas leak or lithium that is used is impure. The reaction of lithium with water is a redox reaction. Identify the oxidizing agent in the reaction, giving the reason. Okay, oxidizing agent experience reduction. Reducing agent experience oxidation. So they are always the opposite. Let's find out which compound or molecule experience reduction. So the reaction is 2Li plus 2H2O produce 2LiOH plus H2. this is standard state 0, H is +1, Li comes from group 1, so +1, O is always -2. This -2, oxygen has a oxidation state -2. For H2, it will be +2, and then it will be +1 because it should be only one H. And this one for elements of 0. So as you can see that the one that experienced reduction is element H. Okay, so the answer will be H2O and hydrogen gains electron, because oxidizing agent experience reduction, reduction gains electron, always gains electron. Or you can also answer H2O and H, oxidation state change from +1 to 0. All right, describe 2 observations that indicate the reaction of lithium with water is exothermic. When it is exothermic, the temperature increases. So temperature of water increases because you know lithium comes from group 1, very reactive, so the temperature will increase when it is dissolved in water or react with water. And lithium melts because lithium needs to react with water and it will melt. This metal will melt and release heat. Or pop sound is heard. Okay, electrons are arranged in energy level around the nucleus of an atom. Explain why the first ionization energy of calcium is greater than that of potassium. Increasing number of proton will increase number of nuclear charge. Thus, atomic radius size decreases. Okay, because calcium comes from group 2 and potassium comes from group 1, so the number of proton of calcium of course is greater than potassium. So if greater number of proton, so the nuclear charge is also increases because you know potassium is +1 and then calcium is +2, and number of proton also increases. So increases number of proton, the attraction between the nucleus and the outermost electron in the outermost shell will increase. So this will squeeze the atom, and then this will make atomic radius size decreases or becomes smaller. Therefore, if you want to remove an electron from the atom that has smaller radius, will be a lot harder compared to the atom that has bigger radius, because the attraction of course will be not that much stronger. The diagram represents possible electron energy levels in a hydrogen atom. All models have limitations. Suggest 2 limitations to this model of the electron energy level. So it could be lack of representation of sublevels of orbitals, because you don't see this other orbitals, because actually in reality electrons occupy specific orbitals within energy levels, each with different shapes which affect electron behavior and interaction. But in this model, there is no representation of sublevels or other orbitals. And this only apply to atoms with 1 electron, which is hydrogen. It doesn't extend well to atoms with multiple electrons, In fact, each element has its own unique electron configuration. It's not only one. Okay, or you can also say the atom is considered isolated, therefore does not take into account the interaction between atoms. Okay, meaning it doesn't take into account interaction with other atoms or molecule. In reality, atoms are constantly influenced by their surroundings, such as neighboring atom and electromagnetic field. For example, transition metals, it has a different color when it is bonded to a different ligand, so it has definitely effect from their neighboring atoms. So in this model, it doesn't show that there is no such as interaction between atoms. So you can choose 2 from these 4. Draw an arrow, label X to represent the electron transition for the ionization of a hydrogen atom in the ground state. Ionization, it means the electron is already removed from the atom, so there is no attraction from the electron with the nucleus. So it's from ground state to N infinity, because it's not on the shells anymore. Okay, so this will be X. Draw an arrow, label Z to represent the lowest energy. So the lowest energy, it will be from 3 to 2. Okay, this will be Y. For your information, it's the red with the longest wavelength, lowest energy. All right, the opposite is the highest energy, smallest or shortest wavelength. That would be from 6 to 2. It's violet. Okay, the length of the wavelength is 410 nanometer, so it has high energy, obviously frequency. Okay, but the wavelength is very short. So smaller wavelength will have higher frequency and higher energy. Standard electrode potential values E can be used to predict spontaneity. Iron 2 is oxidized by bromine. Calculate E cell in V for the reaction using section 24 of the data booklet. To calculate E, it's always reduction minus oxidation. Okay, so how do we know which one is oxidation, which one is reduction? By default, iron is more reactive by bromine. Or let's see also from here. You see this +2 and +3 increase in oxidation number, so it's oxidation. Br2 is 0. This one is negative. Okay, negative. So obviously is reduction. Therefore, reduction will be Br and then oxidation will be Fe. So let's see the section 24. All right, so reduction is Br is right here, okay, plus 1.09, and then for Fe, Fe2 plus to Fe3 plus, okay, so that would be this one. Okay, so reduction is plus 1.09 minus plus 0.77, you get 0.32 volt. Determine, giving a reason, if iodine will also oxidize iron 2. Okay, so let's see how is the reaction would be. So 2 Fe2 plus react with iodine will produce 2 Fe3 plus and 2 I minus. Just replace Cbr with I. Okay, so now we calculate E cell, which is reduction, again minus oxidation. The oxidation will be the same, plus 0.77 because still Fe, but now it's I. So let's check for I is plus 0.54. 54. You will get negative 0.23. So because the E cell is smaller than 0, iodine will not, okay, iodine will not oxidize iron 2. All right. Molten zinc chloride undergoes electrolysis in electrolytic cell at 450 degrees Celsius. Deduce the half equation for the reaction at each electrode. So I'm just gonna try to explain right here. So ZnCl2, that would be 2 plus and Cl minus. Okay, so we have panic here. So positive will be anode, negative will be cathode, and cathode always reduction, anode always oxidation, lose electron, gain electron. So Cl will go to anode because Cl minus will attract to the positive electrode, and Zn will attract to the negative electrode. Okay, so Cl will experience oxidation, which is losing the electron. So that would be 2 Cl minus and losing the electron. So 2 Cl2, 2 gas, and zinc will experience reduction, produce certain liquid. Okay. Deduce the overall cell reaction includes state symbol. Use section 7 of the data booklet. That would be Cl2 liquid will produce certain liquid and Cl2 gas. Okay. Hydrogen and iodine react to form hydrogen iodide. The following experimental data was obtained. Deduce the order of reaction with respect to hydrogen. Okay, for hydrogen, we need to find which experiments are the same in the I2. So these are the same. Okay, so that would be the experiment 2 and 1. As you can see, 6 divided by 2, so it's 3. So it's double the concentration. And we'll see here 3.6 divided by 1.2, and is also double rate. Okay, so for H2, that would be first order. If it's double the reaction, double the rate will be first order. If it's double the reaction, quadruple the rate will be second order. If it's double the reaction, the rate doesn't change, it means zero order. Deduce the rate expression for the reaction. So we need to find out for H2. H2 is first order, and for I2, this is the same. And you can see also here, double the concentration, double the rate of reaction. So for I2 is also first order. Therefore, rate will be K, H2 first order, and I2 first order. Calculate the value of the rate constant starting its unit. So K will be rate divided by H2 and I2. You can choose any of this number. You just plot into the formula. Okay, I will choose the first one. So 1.2 times 10 to the power negative 6 mole decimeter cube s to the power negative 1. Don't forget to add the unit because it's very important. So concentration of H2 would be 2 times 10 to the power negative 3 mole decimeter negative 3 times concentration of I2 3 times 10 to the power negative 3 mole decimeter negative 3. Okay, so negative 3 and negative 3. All right, so I can eliminate, and this one eliminate as well. So the answer will be 0.2. Now mole will go up, decimeter cube, and S negative 1. Okay, state two conditions necessary for a successful collision between reactants. Of course, the energy should be bigger or same with activation energy for the reaction to proceed, and it should have appropriate or correct orientation. All right, state the equilibrium constant expression Kc for this reaction. The reaction is H2 plus I2 produce 2HI. So Kc will be HI to the power 2 because the coefficient is 2, and then H2 and I2. Consider the reaction of hydrogen with solid iodine. Calculate the entropy change of reaction. That would be product minus reactant. So the product is 2HI. So 2 times 206.6 minus reactant H2. That would be 130.6. Okay, plus I2 116.1. Then you will get 166.5 J per K mole. Predict giving reason how the value of delta S reaction would be affected if I2 were used as a reactant. Okay, so if we use I2 were used as a reactant, gas, all right? If we see here, it's solid. Okay, so the solid and the gas, so one molecule of gas and then two molecule of gas right here, therefore increase in gas molecule. So if increase gas and molecule, it will increase the entropy. But what if we have now two gas mole, because I2 now become gas, and then two HI gas as well on the right side. Therefore, there is no change in number of mole. It means delta S reaction lower as the same number of moles of gas, because the first one it's solid, so there is increase in delta S, right? But when you change it to be gas, there's no increase, so delta S number will decrease compared to when I2 is in solid state. Calculate the Gibbs free energy change in kilojoule per mole for the reaction at 298 Kelvin. So section 1 is the equation, which is delta G delta H minus T delta S. It's 53 kilojoule per mole minus 298 times 0.1665 kilojoule per k mole. So delta S, we got it from here, and then for delta H, it's known. Okay, so delta S is in kilojoule, and then delta H also is in kilojoule, so they're good. You get 34 kilojoule per mole. Calculate the equilibrium constant Kc for this reaction at 298. Use your answer to D3 and section 1 and 2. So ln Kc will be delta G divided by RT. You can get this from section 1 data booklet. The equation is provided. So ln Kc will be negative 3.4 times 10 to the power 3 J per mole. Okay, because we convert it into joule, divided by 8.31 joule per k mole. That's the reason why we convert it to be joule, because the gas constant is in joule, times 298 Kelvin. So ln Kc will be negative 1.37 and Kc will be 0.25. Iron 2 disulfide Fe(S2) has been mistaken for gold. State the full electron configuration of Fe2+. Okay, Fe, that would be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. And for Fe2+, you will remove 2 electron for orbital s. So everything the same, you just put 3d6, or you need to repeat again, not like how I did it. So AR with short notation, 3d6. Explain why there is a large increase from the 8th to the 9th ionization energy of iron. Okay, as you can see here, okay, iron, if it's 4s2, okay, let's say 4s2, okay, it has 8 electron on the outermost shell, so it's easier to remove 8 electron. All right, but for the 9th one, it is more stable. The electron is more tightly held by nucleus, because you try to take 1 electron for the noble gases, which is AR. All right, does make sense? So it is easier to remove 8 electron, as they are in the outermost shell, but ionization, the 9th ionization energy is more stable, as electron is more tightly held by nucleus, or electron is closer to nucleus. Okay, calculate the oxidation state of sulfur in Fe(S2). Fe(S2), you know, Fe2, iron 2, it means +2. This one will be -2, but remember is S2, so -1. Describe the bonding in iron Fe. It's a metal, so metal bond is the electrostatic attraction between lattice of cations and delocalized valence electrons. Okay. Outline giving a reason the effect on the catalyst on a reaction. Even though it's an equilibrium reaction, it will increase rate of reaction and lower activation energy and provide alternative pathway. The reaction between sulfur dioxide and oxygen can be carried out at different temperatures. On the axis, sketch Maxwell-Boltzmann energy distribution curves for the reacting species at 2 temperatures. The y-axis will be fraction of particles, okay, and this will be kinetic energy. So the first one will be, the peak will be quite high, okay, and then you just need to make it a little bit nice here. But the second one is more down, okay, so this will be T1, this will be T2. So higher temperature, lower temperature. Higher temperature, it must be slightly moved to the right and has lower peak, because we need to show it has more particles that have higher kinetic energy. Okay. Explain the effect of increasing temperature on the yield SO3. So the reaction is 2SO2 plus O2 will produce 2SO3, because the delta H is negative 196 kilojoule per mole. So the forward reaction will be exothermic and the reverse will be endothermic. So increase temperature will cause equilibrium shift left and the yield will decrease. Okay, so because this reaction is exothermic, okay, so when we increase the temperature, it absorbs the energy and it will favor endothermic reaction. So when it favors endothermic reaction, it will reverse, right? So the equilibrium will shift to the left. Of course, the number of product will decrease. Draw the Lewis structure of SO3. The Lewis structure will be like this. Okay. Or you can also try to make with the one that can experience resonance. That also correct. It is accepted as formal charge is not being assessed. Explain the electron domain geometry of SO3. It has 3 electron domain. They repel as far away as possible, causing 120 degrees apart. Okay, electron domains repel each other due to the principle of electrostatic repulsion, which arises from the negative charge carried out by electrons. Since electrons are negatively charged particles, they repel each other when they are close, causing them to spread out as much as possible, resulting characteristic shapes of molecules and molecular geometry. State the product form from the reaction of SO3 with water, because there is sulfur that would produce sulfuric acid. State the meaning of a strong bronzed lauric acid. Bronzed lauric is a proton donor. that fully dissociate because it's strong. If it's weak, partially dissociate. The overall equation for the production of hydrogen cyanide is shown below. State YnH3 is a Lewis base. So as you can see, this, as you know, Lewis base donates pair of electron, and NH3 as a lone pair. Okay, so YnH3 is a Lewis base because it donates pair of electron. All right, calculate the pH of 1 times 10 to the power negative 2 molar aqueous solution of ammonia. So Kb will be 10 to the power pKb, which is 10 to the power 4.75, and you get 1.78 times 10 to the power negative 5. And if you know Kb, so you can find concentration of OH minus by doing Kb times M. So if you plot the number, that would be 1.78 times 10 to the power negative 5 times 1 times 10 to the power negative 2. You get 1.78 times 10 to the power negative 7. Then it would be 4.2 times 10 to the power negative 4 mole decimeter cube. And you can get POH by doing negative log of this number, and you get 3.37, and pH 14 minus 3.37, which is 10.6. Justify whether 1 decimeter cube solution made from 0.1 mole NH3 and 0.2 mole HCl. Okay, so to make a buffer solution, you need weak acid and conjugate base. So this one is no, as they are not a pair of a weak acid and conjugate base, or no, weak base will be neutralized as weak base is not in excess. It's not only using a pair of weak acid and conjugate base to make a buffer solution, you also need a large amount of weak acid, but weak base. So therefore, they are not suitable to make a buffer solution. Okay. Sketch the shape of one sigma and one pi bond. Sigma should be overlap. Okay, so there is atoms approach each other, or you can say also with pi electron. Okay, also with this. All right, so overlap region. And for pi, that would be like this. Okay, side to side overlap. Two orbitals from neighboring atoms overlap perpendicular to the axis of approach. Identify the number of sigma and pi bond in HCN. HCN. So single bond 1 sigma, and triple bond there is 1 sigma and then 2 pi. So that would be 2 sigma and 2 pi bond. State the hybridization of HCN. HCN. It has 2 domain, that would be sp. If it's 3 domain, that would be sp2. If it's 4 domain, that would be sv3. Suggest why hydrogen chloride HCl has a lower boiling point than hydrogen cyanide HCN. Okay, so HCN has a stronger dipole-dipole attraction. As you can see, HCN and this one HCl. So it has a triple bond, but single bond is only one. And when you have triple bond, the attraction is a lot stronger compared to single bond. That's why HCN has stronger dipole-dipole attraction. Explain why transition metal cyanide complexes are colored. In its three reasons. The first one, partially filled d orbital, and then Cn causes d orbital to split, or light is absorbed as electron is promoted. Okay, partially filled d orbital. Cn, that is acting as a ligand, is donating a pair of electrons into vacant orbital of the transition metal, like for example 3d, 4s, or 4p. So the ion of the transition metal has a partially filled orbital, or has a vacant orbital, and Cn causes the orbital to split because due to the effect of a ligand field, it causes splitting, creates energy levels within the d orbitals. You know, there are two different energy levels, or the orbital will split into two different energy levels, and light is absorbed as electron is promoted. The color of transition metal cyanide complexes arise from the absorption of light energy by electron transitioning from the ground state to excited states. So it's absorption, not emission. Okay. C60 and diamine are allotropes of carbon. Outline two differences between the bonding of carbon atoms in C60 and diamine. C60 and diamine. Okay, C60 bonded to 3 carbon. This one bonded to 4 carbon atoms. And this one sp2 because 3 domain, and this one sp3 because 3 domain. And also it has pi electron free to delocalize, but this one not delocalize. Okay. Explain why C60 and diamine sublime at different temperatures and pressures. Diamine has covalent network solid and sublimes at higher temperature and pressure. It means it can turn directly from solid to gas, sublimation. Or, sorry, N because it's 2 point. C60 has molecular structure with London forces. Okay. State 2 featuring showing that propane and butane are members of the same homologous series. Of course, because it has the same general formula, which is CnH2n plus 2, and it differs by CH2 or repeated CH2 unit. I cannot answer this question because there is no picture, because it's removed for copyright reason. Describe a test and the expected result to indicate the presence of carbon-carbon double bond. So to check whether it's alkene or not, by adding bromine water. So bromine water, it has a orange color. So if it's alkane, orange color will turn into will turn colorless. Okay, if it's alkane, the orange bromine water will not change. The color will stay the same. Draw the full structural formula Z-butene. So this will be cheese, same site. So that would be its same site. If it's not, then CH3 will be here and H will be here. So it's not going to be, sorry, H will be here, CH3 will be here. So it's not going to be the same side. But it's same site, which is cheese. Write the equation for the reaction between butene and hydrogen bromide. So one will be right here and Br will be right here. Okay, state the type of reaction. That is electrophilic addition, because it's adding, right? Electrophilic, so electrophile is a molecule of atom that seek to accept electron to form a new bond. They are forming a new bonds here, single bond H and Br. Suggest two differences in the HNMR of butene and the organic product. So butene, okay, so that would be C, H, 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 C, H, H, and then, sorry, so this should be C, and then that would be H, C, H, H, H. Okay, symmetrical. So this CH3 and this CH3, H on this CH3, CH3 will be the same, and this one will be the same as well because it's symmetrical. So butene will have two phenols only. But for the product, that would be CH3, C, H, and then H, C, Br, and then H, and then C, H3. So this H will not be the same with this H right here, because the C attached to the C that attached to Br, but not for this one. And this one obviously not, because it's 2, and this one is only 1. So product will have 4 phenols. And for the chemical shift also will be different. So as we can see on the chemical shift here, the first one, butene, it's 4.5 to 6 because it's double bond. And for the product, it has halogen, so between 3.5 to 4.4. Okay, they have the chemical shift. So chemical shift here is 4.5 to 6 ppm, and this one chemical shift is 3.5 to 4.4 ppm. Okay, predict, giving a reason, the major product of reaction between butene and steam. So CH2 double bond C, OH, and then CH2 CH3 plus H2O. This butene, okay, so this one should be H. So what will happen? So this H and then OH, one will be OH and another one is H, but we'll see what the product, major product would be. Why is it on the on the second C? Because if we add on the first C, it's not a secondary carbocation. Okay, if we add into the first one, we have only one alkyl here. But if we add into the second one, we have this alkyl and this alkyl group. And secondary carbocation is more stable than the primary carbocation. Therefore, the major product will be on the second C because it is secondary carbocation. Explain the mechanism of the reaction between 1-bromopropane, which is like this. Okay, 1-bromopropane. So that will be H and will be H. And aqueous sodium hydroxide. So OH, it has lone pair, OH minus. So it will go here and produce the inside the bracket. That would be Br, that would be OH, that would be H, and here H, and C2H5. Okay, and then the leaving group will leave, then you will have C2H5 OH and Br minus. So this reaction mechanism occurs by breaking the carbon-bromine bond due to nucleophilic is attracted to carbon and form transition state. The chemical structure in the bracket is not considered as the intermediate product. It is a halfway step in the reaction due to atom being broken and made continuously. So it continues with the departure of bromine atom as bromine ion and produce propanol. Deduce the splitting pattern in H&MR spectrum in 1-bromopropane. So 1-bromopropane will be like this: CH2, CH3, 1-bromopropane. So you will have one H environment and the other one and the other one, because now the C is attached to Br. So the first one, A, will be triplet because it's neighboring next door to CH2 group, and the B1 is neighboring to CH3 and CH2. So we can say multiplet because you guys learn only until quadruplet. And then for the C, CH2 this, okay, is neighboring to CH2. Therefore is triplet because next door to a CH2 group. Okay. The next one, calculate the enthalpy change of the reaction, delta H, using section 11 of the data booklet. So you guys just need to make the Lewis structure, CH4 here, and then Cl, produce CH3 here and bonded to Cl, and then HCl. So you guys will have 4CH plus Cl, produce CH, okay, CH, that would be 3, plus CCl plus HCl, that would be 4 times 414 plus 242, produce 3 times 414 plus 324 plus 431, and here total 1898, and this one is 1997. So delta H will be 1898 minus 1997, that would be negative 99 kilojoule. Draw and label an enthalpy level diagram for this reaction. This reaction is an exothermic reaction. Therefore, the enthalpy of reactant is higher than product. Okay, so this will be the activation energy, and then delta H is negative because the energy is lost. All right, so that's all for the explanation chemistry level paper to May 2022 times on 2. I hope this video is helpful, and if you find this video is helpful, don't forget to subscribe and let your other friend knows about my channel as well, so you can support me and you guys can study together. So that's all for today. Bye for now.